Let's talk about the allowances, due to which patterns are made slightly larger than the actual casting. These allowances are shrinkage allowance, machining allowance, pattern draft, fillets, wrapping allowance, and distortion allowance. Let's discuss them one by one. First, we have the shrinkage allowance. When a molten metal solidifies, what happens? It shrinks because all metals shrink because of the interatomic vibrations, which is amplified by the increase of temperature. Since metal shrinks on solidification and contracts further on cooling to the room temperature, linear dimensions of the pattern are increased in respect to those of finished casting to be obtained. And this increase in the dimension of the pattern, that means making the pattern slightly larger than the casting, is what we call shrinkage allowance. It is generally given in millimeter per meter. The shrinkage allowance for various metals are listed here. Now let's understand this allowance, this pattern allowance, the shrinkage allowance in greater detail. For that, we have a graphical representation here. Temperature versus time graph is being made. The T suffix P here is nothing but the pouring temperature, that is, the temperature at which the molten metal is poured. Tm is the melting point of the metal, and Tr is the room temperature. The pouring temperature is generally 150 degrees to 200 degrees Celsius higher than the melting point of the metal. The reason behind the same is we don't need solidification in the early stages. We need solidification of the metal with proper timing. Otherwise, solidification might start in the entry of the gating system, in the sprue or in the runner, rather than being in the cavity. All these terminologies will be discussed in the gating design, so you don't have to worry about that. Just try to concentrate about what you have to learn from pattern allowance. Now this whole process is bifurcated into 3 stages. The stage 1 is the liquid shrinkage, in which the molten metal is poured and flowing through the gating system. The second phase is the phase change shrinkage, in which the liquid metal starts to turn into solid. And during this time period, temperature remains constant for certain time because latent heat is being released. And latent heat was what? Latent heat is the hidden heat. And the third stage is the solid shrinkage. That is, the molten metal has started the solidification process and shrinks. The shrinkage that occurred during the stage 1 and stage 2 of this whole process, that is the solidification of the molten metal, is compensated by providing extra molten metal from a standby reservoir, that what we call a riser. However, for stage 3, that is the solid shrinkage, we need to provide certain allowance, that is what we call shrinkage allowance, and make the pattern slightly bigger, and hence the cavity. The next allowance is known as the machining allowance. I must have told you in the very beginning that the casting components that is created by casting process are not dimensionally accurate. We need to provide further machining to get the desired outcome. and hence machining allowance has to be there. It is also known as finish allowance, and it indicates how much larger the rough casting should be over the finished casting to allow sufficient material to ensure that machining will clean up the surface. This machining allowance is added to all the surfaces that are to be machined. There are certain factors that affects machining allowance. These are material and size of casting, the volume of production, the method of molding, and last but not the least, the configuration of the casting. The third allowance is what we call taper or pattern draft. It is also termed as draw. As you can see in this particular figure, if a pattern is not tapered enough, it will in turn crumble or basically destroy the sand mold, and hence the cavity will not be dimensionally accurate. The cavity will be distorted, the cavity will be damaged, and hence the casting will come out to be a faulty one. And hence a taper is placed on the pattern surface that are parallel to the direction in which pattern is withdrawn from the mold. The withdrawing tendency of the pattern from the mold is perpendicular to the parting line and the parting plane. If taper is not there, the removal of pattern would definitely damage the mold cavity. Again, you can see the figure with draft with taper allowance and without draft or taper allowance. In both the sides, the one with the draft or the one with the taper is easily getting removed from the molding sand and hence leaving a good cavity. However, without the draft, the sand is getting crumbled and the cavity is getting disrupted. Next we have corner and fillets. The intersection of surface in casting must be smooth and they must not form sharp angles. For the same purpose, the external and internal corners of patterns are suitably rounded. That is what we call a fillet. Next we have wrapping or shake allowance. Now to take pattern out of the mold cavity, it is slightly wrapped to detach it from the mold cavity. Due to this, the cavity in the mold increases slightly. Patterns are hence made accordingly. And last but not the least, distortion allowance. This is considered only for casting which is having irregular shape, which are distorted in the process of cooling because of the metal shrinkage. So these allowances are there which are very much important when designing a casting system.